It often happens that you need to do some output from an assembly language routine. The best way to do that is by using the C library of output functions sitting on your machine. Let them do all that low-level stuff. I've got here a couple of examples of output routines. Using the C library makes the outString function a very simple assembly language function. All it does is call the printf function of the C library. Now the first argument to printf is the format string, and the same format string is used every time in these examples. Notice that it has a 0 byte for a terminator on its end. That's because C expects it that way. This is the body of the outString function. The C function name is declared as an extern. With these two instructions, everything is saved on the stack. The push AD instruction is a handy opcode. It pushes the registers EAX, EBX, ECX, EDX, EBP, and ESI, and EDI all on the stack. The pushFD opcode pushes the flags onto the stack. The last argument to be passed to a function is the first one to be pushed on the stack. This is the address of the string to be printed. By pushing it on the stack first, it will be the one on the bottom inside the function. The next argument is the string used for formatting. It's necessary to specify the length as a D word in this instruction because the push mnemonic is ambiguous. Then the function is called. Then, before exiting the function, the registers and flags are popped off the stack and restored. Another function in this current module is one that lists the names of the flags that are currently set. Now here, at the top of the module, are some defined constants in hex form that have a bit set for the flag it is to check. The constants are defined using the preprocessor, which is explained in detail later. This list doesn't include every possible flag, but it does include the ones most commonly used. You can always add new ones if you find some you need to add. The function prints the names of the flags, and this is the list of strings of flag names. This last string is a utility string that consists of nothing but the new line character. This is the outFlags function. At its entry, all the registers are pushed onto the stack. Then a copy of the flags is made into a work area. The program could just as well work by reading the flags from the top of the stack instead of this work area, but to do so you would need to be careful about how you use any pushes and pops inside the function. It's easier to just make a copy. To test a flag, it is first necessary to load the working copy of the flags into a register. The test opcode is a bitwise AND of two values, the set of flag bits and the bit being tested. In this case, the carry flag. If the flag was not set, the result is 0, and the next couple of instructions are skipped with this jump instruction. If it was set, the outString function is called to output the name of the flag. The same code is executed for each flag down through the function, so the names of the set flags are all output. After the test of all flags has been made, and output has been generated for each one that was set, a new line character is output, and the function ends. There is one more function. During development, you will find that you need to check the contents of the registers. These two lines are used to format the register values into output strings. One formats the values into hex, the other into base 10. Which one you use depends on how you want to look at your values. Here at the very bottom is one of the register output routines. This one displays the registers in base 10. It pushes the register values on the stack as arguments to the printf function. Notice that they are pushed onto the stack in the opposite order they are to appear on the print line. Finally, the address of the printed format string is pushed onto the stack, and a call is made to the printf function. When the function returns, it is the responsibility of this function to remove the arguments from the stack. You can do this in a couple of ways. A series of pop commands could be used to clear the stack, or, as in this example, 20 is added to the stack pointer. Either way, the stack information is simply discarded. The other register dump routine is exactly the same, except it uses a different format string. So the register values will be displayed in hex format. This is how you call these routines from an assembly language function. The first function, named show, is an example of a program that outputs a string. The string to be output is formatted by being ended by a new line character. 10 is the ASCII value of a carriage return, and it's terminated by a 0 byte. The address of the output string is pushed onto the stack, and a call is made to outString. Because the outString function is in another module, it is necessary to declare it as an extern. In this second function, the compare instruction is used to set some flags. Then the outFlags function is called to display the list of whatever flags is set. This third function at the bottom, called registers, sticks a recognizable value in EAX. Then it calls the register dump functions to display all of the register values, first in hex and then in decimal. The main line of the C program calls the three functions. First it calls show to display the string, then it calls flags to set and dump some flags, then it calls registers. All these functions are useful when you're writing assembly language programs. You can debug things by displaying strings that track your progress through the code. Also, if your program isn't branching the way you think it should, you can insert a function call to check the flags, and you can always check the registers to make sure they're holding what you expect them to hold. And this is what it looks like when you run it. You can change this to display the flags in a different way if you wish, or to display other registers, or you can combine them into one program that displays everything. Whatever you need for your debugging purposes.